pa, 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 pam. Pa. Ojejku. Chyba tutaj zyskuję. Ojejku, no. Prawda? No już. Mm, mm, mhm, mhm. O kurde. Czy tutaj będzie. Aj. Jest jednak. O, tak trzeba może. Może tak? Tak by było chyba lepiej. I... Masz mi tutaj możliwość przyczepienia tego. O. Um, a. O. Tak. Zostawić tutaj. O. Tu. Tu. Pa, 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 pam. Okej, chyba wszystko działa. A, jedna rzecz nie działa. Oczywiście. Ciekawe. Dlaczego? O, teraz działa. Super. Nice. Działa. Myślę, że jest ok. Ok, na to co wygląda. Dobra. Czy ja zrobiłem wtedy... Czekaj, bo tutaj były... Zacząłem routing? Nie zacząłem hard routingu. Tables. Czyli jak jest daleko. Not basic routing. Subnetting mam zrobione, bo subnetting wiem, że pamiętam, że miałem. Not też. Czyli tutaj był Network Cables. Czyli Network Cables, bo tu Switch Basics będzie. O
Hello there.
matko, to jest bardzo fajne. He got up. Przygotowałeś wodę? Tak. Mam obok.
Let's do some switch basics.
O.
Because switches are so
Teraz
widely
nie wiem,
used
czy to jest za
nowadays. You find them
głośno,
in
czy
pretty much
nie.
every LAN you'll come
Bo
across.
mikrofon mam w ogóle dosłownie po innej stronie. Dosłownie tam. To jest jeden monitor, to jest drugi monitor. Więc dzięki. Jest tego. Być tego. Ok, zakręcone, dobra. Muzykę też walnę dalej. Pa, 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 pa. Nie. Najgorsze, że muszę mieć tą nazywa klawę na kolanach. Nie mam miejsca na biurku. Ja tak chcę robić. Czyli mieć możliwość, żeby był widoczny po prostu ekran od zeszytu. I dalej kluczowanie mi wywala całkowicie ten kolory żółty, zielony i niebieski, o dziwo też, bo jest za mocne, bo no delikatnie jest za mocne, bo widzę obwódkę wokół palca. No cóż, co zrobię? Muszę jakoś to mieć. Dobra. Switch Basics. Mam tutaj swoje kolorowe te. Mam. Nie będzie ich widać. Bo oczywiście tak. Zielony, to jest żółty, tu jest różowy i niebieski. Tylko oczywiście kluczowanie będzie wywalać, bo as usual. Teraz powinien być różowy. Dobra. Karteczka. Więc gdzieś tutaj. I to będzie Switch Basics. I zapisać jeszcze na tym. Okay, Switcha. Switche są fajne, przyjemne i bardzo pożyteczne, bo nie pamiętam, czy tutaj będzie od razu opisane VPN-y. Nie, VLANy będą niżej. Znaczy VPN-y, no. I też coś czuję, że ta muzyka jest za głośno. Zarąbisty YouTube Music. Dlaczego nie mogą zrobić po prostu aplikacji z Twitcha? Oczywiście nie mogą nigdy. O, nie będzie tyle. O, i niech będzie. Dobra, lecimy. A tam co u was w takim razie się dzieje ciekawego? O, na OBS będę siedział zaraz na tym. Chciał po prostu bliżej ten wiadomości.
But before we can appreciate why switches are so special, we need to talk about some of the things that came before them. So let's do some pre-switch technologies. And the main LAN device that predates switches in a way that you would recognize a LAN as a LAN would be hubs. Now, the symbol for a hub is usually a square with one arrow in one direction, although I have seen some icons and templates that
Huby
use
są
two arrows, but
śmieszne.
they'll always be pointing in the same direction. Now, a hub is what we call a multi-port repeater. It has multiple interfaces and is designed to repeat the signals it receives.
Yep.
So it basically works at OSI layer 1,
Jest
it's a
to
purely physical
layer
device.
egzaminy.
And its
O,
method of operation can
jak z tym egzaminami ci idzie? Właśnie. Bo słyszałem, Aurien swoje pozdawał. Zmiana obiad. O, to super. Bo Aur mi dzwonił wczoraj, że się mu udało, ma zdany sieci, więc git. Ja mam jutro dopiero. Mhm. No to powodzenia w takim razie. Multiport repeaters. Które wywalają cały sygnał i wyrzucają nawet całość na inne. Takie same co z angielskiego. A, to raczej nie będzie tak źle. Pewnie będziesz miał ustny, będziesz miał troszeczkę po prostu zwykły, normalny, oprócz że ustnego nie robi. U nas ustny olała totalnie. Zapytała się kilka pytań tylko. I mieliśmy losowanko z pytań informatycznych. Będą się mógł wykazać moim radomem angielskim poznane z filmików na YouTube'a. Okej, to też nie tak źle. Bo tak naprawdę angielskiego nie ma nigdy wielkiego problemu. Raczej nie powinno być wielkiego problemu, bo chyba się ogarniasz. English. Language of London. Big London. Tak. Bo to był język angielski zawodowy. Więc mieliśmy tylko i wyłącznie pytania typu informatyczne. Typu z czego składa się komputer. Typu jak rozwiązać problem, czyli troubleshooting, czyli na przykład sobie nie działa konkretny program i masz step by step, czyli po kolei po prostu wytłumaczyć, jak rozwiązać ten problem. A mi nie jest wstępie z prezentacji, więc tylko to mnie irytuje. A, czyli co, chciałeś się z wami dogadać tak, że jak sobie ten
Can be remembered in one
prezentację
single
ogarniecie, to
sentence.
będzie spokój.
It receives a signal, it amplifies that signal, and then it sends that signal or repeats it out of all of its interfaces. So if I were to connect a couple computers to this hub, and let's say the one on the left is the source of the traffic and the one in the middle is the destination. The traffic would make its way from the source computer to the hub and then out that interface to the destination. But it repeats it out of all interfaces. So it's going to go to that third computer who's just sitting there minding its own business, and now it's receiving traffic that is going to have to process and work out, oh, that's not meant for me. Now that doesn't sound too bad in a small network like this.
Okej, chyba mi się
But
wydaje, że
let's
tego
scale
Brave'a
that up.
troszkę przycisza.
Let's say
Jest
we've
dość
got multiple
głośny.
hubs and multiple computers connected together.
Minus
And let's say the source
3
and the
decybela.
destination are both on the left hub there. The source computer sends
Okej, bo tutaj, o kurde. I nie wiadomo, tak bo miał nie wiem, spoko prezentacja, bo pomaraczy, bo opierał się o ścianę. Aha. No to troszkę XD, że tak zrobiła, tak nie powinno się robić, ale no dobra. Pytanie o rzeczy biologiczne na poziomie gimnazjum albo nie biologiczne. Znaczy wiesz, te pytania informatyczne były takie też na poziomie technikum, gimnazjum, takie bardzo dość proste, tylko że wiadomo, no nie każdy gada po angielsku. Nie zostało. O kurde, chyba nic. I ja pierdzielę. Nie będę miał znowu piórka. Żadnego dopisałem. No niestety tego upisałem po prostu. Czyli nic nie ma już. Zresztą zbyt lekkie się wydaje. Dosłownie krytyka do jego preszkił masakra. Niby są specjalne, ale no nadal niski poziom. No tak, to nie jest taki poziom, że you're speaking English perfectly with a person and explaining some IT stuff that you should be doing with your computer about security, etc. Jest to troszkę wiadomo, różnie to wygląda. Scrolla. Ja miałem. Akurat na mnie trafiło pytanie o temat zabezpieczeń, więc ja praktycznie przegadałem 15 minut momentalnie. Jakiś czas. No, normalne. Ale lekcje akurat mieliśmy prowadzone tylko i wyłącznie po angielsku. Fajnie było. Okej, muszę ten diagram, który tam jest na górze, rysować tutaj. Więc najlepiej by było go zrobić ołówkiem z tego powodu, że nie chcę po prostu później mieć rozrysowanego źle. Zostawiam. Nie zostawię. Wezmę. Linieczkę będę miał. Znaczy ekiera. Nie mam. Czyli tak, będziemy mieć tutaj peceta, który będzie source'em. Mamy destination na dole. I będziemy mieć huby. Z hubami jest taki problem, że tutaj nie będzie go widać. Tak, tutaj go nie będzie chyba widać, tego problemu. Gdzie hub? Czyli prostokącik z jedną strzałką. Dobrze, pystek. I fucking knew that you will do it. Dobra, pytanie teraz takie. Jaką grę? I did it. I did it. You spend your all money on this. What game do you want me to play, Mister Pisztek? Ale będę... O! Jejku, czuję. A. Jo, trzeba ci zboostować zasięgi. Okej. Hej, Kaniko. Cześć. Żyję, jakoś żyję. No. Żyję i się uczę. Eee, shit. Czy jednak lobotomii? Lobotomii Corp.
Push-ups now. Go do them, you slacking demon.
Powinienem to wyłączyć. Aj. Jep. Zapomniałem jak wyłączyć z tych na dzisiaj. Ale no cóż. Dobra. Co do lobotomii, no masz rację. Bym musiał sobie troszeczkę zagrać. Więc no. Czy mi kabel pozwoli? Nie pozwoli mi. Muszę ściągnąć sławę. Nie, 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 nie. To jest twój wybór. Nie mój. Ty wybierasz. To jest twój wybór. Nie. To jest twój wybór. Tak mówicie. Dziesiątki nie zrobię. Na pewno nie zrobię. A. Krzesło. I. Więc to jest całkowicie twój wybór. Ja go nie kwestionować nie będę. Obydwie gierki mam i tak. Lobotomii mam chyba od... Czy lobotomii mam kupione? Ja nie pamiętam teraz. Bo Huoniu mam na pewno z twojej biblioteki, bo to wiedziałem. I to nie mam też problemu po prostu ograć, bo mam od ciebie pożyczone, więc nie ma żadnego problemu. Ze samej mechaniką to mi też da. No tak, 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 tak. Więc lobotomii będę musiał sobie... Okej, troszkę przesunę, muszę wejść na centrum. Bo już przesunąłem po prostu na kolejną stronę. Ten. Więc to możemy też ogarnąć, bez żadnego problemu. Że to okej. To się nie skończyłem. No ja się domyślam, bo po gazie, którym oglądałem, to chłop powiedział, że 350 godzin i zrobił trending wreszcie. A myślał, że zrobi to w 700. Więc no, giera jednak jest potężna. Pod tym względem jest dość trudna. Mało? To miał. Czokotek? Wow. Przyszedł mi takie kocisko. Ale dobra, wiadomo. 171 godzin. Zobaczę, czy ja będę miał taką cierpliwość do tej gry. Ale dobra, i tak ten diagram za chwilę będę musiał uzupełnić, bo oczywiście... Znaczy, ja mogę go uzupełnić już samemu. Naprawdę. Bo jako, że to są huby, czy to jest hub? Wow. Miał. I kocie, wow. To sygnał z Source'a to być Destiny, czyli Destination będzie tutaj. Przejdzie na huba, z huba wyjdzie tutaj, z tego wyjdzie do kolejnego huba. Hub wie, że to stąd przyszło i rozejdzie się tutaj. Na każde po prostu urządzenia, które są w sieci. I teraz nie pamiętam, czy jeszcze cofnie. Bo huby były dość
As it's
nieoptymalne.
traffic, and obviously it goes out the other interface to the destination.
Tak.
But remember, it's going to go out of all interfaces. So it's going to go to that hub on the right there. And now that hub is going to do what the first one did. Take that signal, amplify it, and send it or repeat it out of all interfaces. So those two computers over there get stuff that they're not meant to get.
Więc
They have to
nie,
process this until they work out this is not meant for them.
nie ten kota nie
So
pokażę.
to try and introduce some usefulness and intelligence
A, bo
into
się
our
biją
network,
teraz.
we
Dziady.
introduced bridges. Now, the icon for a bridge is this thing. Sort of
Yep.
looks like a suspension bridge without the two parts on the side going down to the ground on each side of the canyon.
Już nie
I have a very visual mind, I'm sorry.
pamiętam.
And it was our very first major layer 2 device for
Okay.
LANs. Now, being layer 2, it is able to work with MAC addresses, and it will learn the MAC addresses from the frames that it is processing. And as it learns those MAC addresses, it associates them with the interface that it received the frame
Właśnie,
on.
Niko, jak tam u
So that
ciebie?
means that when a computer is connected to a bridge in any way, when traffic
Dobra,
it sends
to
reaches
nieco.
that bridge is going to pay attention to the source
To
MAC
smak
address
i
of the frame or the layer 2 traffic. And that bridge will now remember that MAC address of 0102030405AA and associates it with that interface. So if we take that network we were looking at just now and take that cable out from between those two hubs and stick the bridge in the middle.
Tak.
What?
Będziemy mieć po prostu możliwość zapamiętywania, na których interfejsach co jest. Nie więcej. Tylko chyba będzie problem taki, że on, jako że jest pomiędzy dwoma urządzeniami, będzie teraz zmieniał zapamiętane dane. Okay, to mamy. Czyli tak, first, major, layer to device, layer to device, learns MAC addresses. Znaczy frame, pakiety. Naprawdę frame, a pakiety to jest to samo. To naprawdę nie do końca, bo zależy od layeru. Fajnie. Nazewnictwo w informatyce jest po prostu zarąbiste i mi to się bardzo podoba. Uśmiech na twarzy i w ogóle. Ale no cóż. I associates it's Mac. Interfaces. I tak. Adres MAC to jest oczywiście MAC samej karty sieciowej albo każdego innego urządzenia. Jest unikatowy. To jest akurat fajne. Więc bez najmniejszego problemu jesteśmy w stanie po prostu określić wtedy, że te urządzenie jest w grupie sieci, na przykład pierwszej albo w drugiej, ale huby są pomiędzy. Chyba tam będzie problem, że pamiętam.
Associates it with that interface. So if we take that network we were looking
Też sobie narysuję tego. Linka, czyli kabelek, jak zawsze. 01, 02, 03, 04. Nie pamiętam już zawsze, jak długi był Mac. 5A. O matko. 05A. Też są dwukropki pomiędzy. 16-kowym zapisane, czyli literki dochodzą do FF. Czyli FF to jest 16. Że mówię? Nie, 16. Jejku, to jest. Jezu, FF to jest chyba 64, a nie 16. Bo F to jest 16. 16. Aż sprawdzę teraz szybko na kalkulatorze, żeby nie pamiętam. Dawa. Kalkulator. Naukowy, nie chcę naukowego, jest programistyczny. Jest programistyczny. Decymalny. FF to było. Nie, 255. Kurde, to jest. Czyli to jest 6 oktetów po 8 oktetów. Ale w 16-kowym. Oktet 8. Jest na sklepie. O! To kotek. Kotek. Mał. Kotek. Co chcesz? Mam cię powiedzieć dobrze. Kotek. Więc no. 6 oktetów. A w ogóle na nim buścicie nie byłem. O ja. Dobra, będę musiał sobie pójść to wejść. No dobra. To do diagramu wcześniejszego. Znowu sobie to rysuję. Tak. Reset. Reset numer 2. Tutaj będzie hubbing. Kolejny hub. PCT. O, cześć Bregus, cześć. Cześć Siska. Hello. Co tam? Co tam, jak tam, proszę pani? Co tam się ciekawego dzieje? O, pasmofobia. Dobra, widzę, że jednak będę musiał bardzo uważać sobie na ten, na keybindy, bo jednak
Just now.
numpad cały czas będzie mi wywalać filmiki do przodu. Okej. Potem sobie grasz z ludźmi, czy tak sama? Nie pamiętam, czy miałeś licznik koloba jakiegoś coś. Udało mi się szybko coś się zrobić. A, ukradł. Ej, tu wpadłeś do mnie tylko napisać, że gracie i za chwilę pewnie będzie znikać. O ty. Nie widzę, że jednak z Krauzerem tam siedzisz jeszcze bardziej. Szybko i bezpiecznie zrobić jedną mapkę. Mapkę? Ten, jedną mapkę. Ale do czego mapkę? Taką... Hmm. Co tam ciekawego? Robiłaś jaką mapkę? Bo to nie
And
kojarzę
take
chyba.
that cable out from between those two hubs and stick
Są
the bridge in
Source,
the
to
middle.
będzie są
What
Desti.
we're going to land up with is a network where a little bit of intelligence will be present.
No,
So obviously we're going to care
racja.
about these guys having MAC
Trochę czasu
addresses.
minęło.
As you can see, I've made some easy.
Okej. Co do maków, po prostu napiszę, że tutaj będzie AA, BB, bo początkowych nie będę spisywał. C i troszkę bez sensu, żebym rozpisywał je całe, bo być te same. Więc no. I teraz tak. Jeżeli dobrze rozumiem.
0102030405AA, BB, CC, DD.
O
Literally, it's
kurde.
the last two digits that differ. Please be aware that when you're
Okej.
tracking...
Jak używasz programów komputerowych, to nie spaliłeś swojego komputerka? To nie zepsułaś go, czy nie wiem. Bo ja wiem, że to z tymi komputerami miałeś zawsze ciężko. Ja mam hate over z tym do map. A do innych ma. Czyli do wszystkiego. Czyli nam do wszystkiego. No cóż, ale co zrobimy? Zrobimy. Mi się bardzo podoba, jak w ogóle jego filmiki z każdym modułem mają tyle samo wyświetleń. Faktycznie. Ludzie się uczą naprawdę na tym. O dziwo. No cóż. Nie mam wymienione baterie, jak sobie radzi. Mhm. No to
In the Network
git.
Plus exam, they might not be as nice with what the MAC addresses look like, so just read them carefully. But for learning purposes, I think we can get away with making this stuff a little bit easier to read and to talk about. Now, as before, we have the same two PCs acting as source and destination. Now, the bridge is going to learn the MAC addresses. We've skipped ahead, and the bridge now magically knows it already. What will actually happen, though, is when the bridge sees new traffic arrive, it'll look at the source MAC address field of the frame, and if it's new to this bridge, it will associate it with that interface. So it now knows that MAC address blah 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 AA and BB is on the left interface, and MAC address blah 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 CC and DD are on the right side. Now we can have the source computer sending some traffic out. The hub that traffic arrives on still does what a hub does out of all interfaces. But this time, we're actually going to be keeping track of source and destination MAC address. So out it goes. But this time, it gets to the destination. Fantastic. The recipient receives it, sees their MAC address in the destination MAC field, and carries on processing it. But the hub still sends that one frame out the interface it actually didn't need to. The hub does it better, so we can't blame it. The bridge will have a look at the source and destination MAC address and go, I see that the MAC address for the source and the destination is on the same interface. There is no need for me to send it out the other side, so the bridge does what's called a filtering decision and chooses not to forward that traffic. So in this situation, it's nice. The bridge has not sent the traffic to the other side unnecessarily. However, what if the destination is on the other side of the bridge? Well, in that case, what's going to happen now? That traffic hits the hub. Source MAC is AA, destination MAC is CC, and the hub doesn't care because it's layout.
Tak to nic nie zmienia, totalnie.
The bridge looks at the source and destination MAC address and realizes, yes, the source MAC is on the incoming interface, but the destination MAC address is on the other side. I better send it out the other side.
Będą i tak rozsyłać każdy kierunek, czyli nic tutaj nie zmieniam. Takie rozwiązanie, czyli bridge są spoko, ale zamiast hubów. Naprawdę. Proszę, no, domyślam się, że i tak było bez sensu, bo switch, zrobić coś takiego jak switcha. Tylko ze switchem jest to inny problem, bo tutaj tego problemu akurat nie ma wpisanego. Jest Mac Bleed, Broadcast Bleed. Chyba Broadcast Bleed to się nazywało? Nie. Że wysyłając po prostu informacje tak, żeby skonfigurować sieć raz za czas. No, switche mogą się zapętlić, co nie jest fajne, ale to jest dużo później, bo to jest chyba dopiero w module 17 albo 11. To jest troszkę później, dużo później. Że coś się uda. To rób powolutku. Ja sam też się teraz uczę, więc no. Będę chciał przerobić ten filmik. Może jeszcze drugi. Bo jak jestem tutaj na 11, ja jestem już na 17 naprawdę, bo na brudnopisie po prostu mam dużo więcej po prostu zapisane. I jak na czysto to robię, to już widzę, że jestem za daleko po prostu do tyłu. Naprawdę. Więc powolutku zaczynam zapominać rzeczy, które już troszkę się uczyłem, więc nie powinien tak robić.
Thankfully, though, when we do look at how switches work, they do this just better.
Tak.
But there's another interesting technology that you need to know about. CompTIA is definitely going to want you to know about something called CSMA/CD. And the reason is we still use it in our LANs, even though we've got switches now. You'll see why I said that the way I said it. So first of all, what's this acronym for? Carrier sense, multiple access, with collision detection. That's what the slash is for.
O matko.
So this is a
Też bardzo fajna rzecz tam z tego kursu, co sobie teraz przypomniałem. A to jest dużo, dużo później. I już wiem mniej więcej, jakie standardy są używane i dlaczego to jest tak skomplikowanie rozpisane. Bo później na przykład przy kupieniu routera i tak dalej jest przy sekcji całej Wi-Fi cały totalny rozpis standardów, które istnieją. I nie jest to fajne zrobione, ani troszkę fajnie zrobione to nie jest. Jest to bardzo denerwujące i szczerze nie wiem, po co ludzie wymyślili tak skomplikowane nazwy. Ale oczywiście jest to zrobione w Ameryce, więc oni sobie wybierali, jak to mogli zrobić.
Ethernet service
Niestety.
designed back in the era of hubs and even before hubs when we used to use something called a bus topology. So this is what a bus topology would look like. A bunch of computers all
O
connected to the
kurde,
same cable.
linia. No,
This was actually very common when we used to use coaxial cables for our networking.
to jest prawda, że było
Now,
kiedyś bardzo
why is this necessary?
używane, bo na ten
Well,
temat też
in a network
rozmawialiśmy.
where everybody
Studia.
shares the same single cable, we have some potential dangers. So CSMA/CD outlines normal communications and its normal conditions and rules for all of these computers here is listen before you send traffic onto the network. When you listen to the network, one of two things will happen. Either the network is quiet, no one's using it, you can send traffic. Or you listen to the network and you hear it's busy right now, you hear someone's using it. You wait till it gets quiet, then you can have your turn. Now that sounds great, but there's a problem with it. What if two computers listen to the network at the same time and come to the conclusion at the same time that it's quiet and they both send at the same time? This traffic starts making its way down the cable. The electrical signals start going to the computers connected, but at some point, these two signals are going to run into each other, and we have now what we call a traffic collision. Now, nothing dangerous is going to happen, so don't worry, but the electrical signals that make up the traffic are going to start running into each other and messing with each other, over amplifying or negating each other. Going to be unpleasant. Now, what is CSMA/CD going to do for us? Well, it says carrier sense multiple access with collision detection. So we're going to detect the collision and recover from it. So when the collision occurs, the first PC that sees or technically hears the collision will send out something called a jam signal. So let's say, for instance, that computer was computer B with a little blue dot above it right now. It sends out a jam signal throughout the network and everyone sees that jam signal. Now, what makes the jam signal special is it lasts for 3 times the duration that a normal network transmission would last. So this jam signal will definitely outlive the collision. So the collision obviously dissipates because the signals eventually stop being sent, but the jam signal carries on going. So we know that all the other computers in the network have heard this jam signal. Now, all the PCs will have to set for themselves a random timer. So they're all going to have a little clock, and they're all going to set for themselves some random times. They probably will not be nice multiples of 10. I just did this for the ease of reading and speaking. But in reality, it'll all be random numbers. Some will say 10 milliseconds, some will say 13, some will be 2. It'll be random, it'll be all over the show. When the jam signal ends, the random timers begin counting down to 0. So the jam signal now goes away, and these timers can start working their way down. But what happens when they reach 0? Well, you cannot send any traffic until your timer reaches 0. However, you can still receive it. Obviously, when your timer reaches 0, you can have your turn. So judging by it, we've got PC A with 10 milliseconds, B with 20, C with 40, and D with 70. So 10 milliseconds will pass, and A gets down to 0 milliseconds.
Nauczysz mi tu, chodzisz mi tu, prosisz. Oha, prosi o jedzenie. Dobrze. Random timer. Oczywiście random do tego stopnia, żeby po prostu tylko mieć czas ustawiony jakikolwiek na całej linii. Pierwsza osoba, która chciała coś wysyłać, czeka, aż timer się kończy, dopiero wysyła. Reszta widzi, że ej, on już zaczął gadać. Łaha, mamy ten. Wracamy do normalnej sytuacji, gdzie sieć po prostu powraca do zwykłego swojego życia. Minus to jest czas kolizji i tego jamu. Nie może nic wysyłać ani robić. Co może się dość często dziać. Tym więcej urządzeń, tym większa szansa na to, że to się wykona. Więc when jam signal and timer zero and send till or is zero can receive 100. Tak, bo inaczej by po prostu nie wiedzieli, że ej, bo jest kolizja, aha. Normalne,
And A can now transmit that traffic.
tak.
Now remember, all the other devices are still counting down, but they can still receive while they're counting down. They just can't send anything, so they can't reply. But that's fine. A got its traffic out. Lovely stuff. Now the timer is carry on running down, and another 10
Tak.
milliseconds pass, and B hits 0. But B's got nothing to say, so it makes no difference to B. Another few milliseconds pass, and C hits 0 as well. C didn't have anything to say, so it makes no difference. Then another 30 milliseconds pass, and D hits 0 and gets its traffic out. And now we
A myślałem,
have
że będziesz robić dalej.
successfully recovered from that collision, and the two devices that caused it were able to retransmit that data. And that's fantastic. And this used to work very well years and years ago when our LANs were pretty simple and small. But obviously, you and I both know our LANs are no longer simple and they're no longer small. So we needed something better. Don't worry, you'll see why. So first of all, collision domains. We want to be able to recognize and identify
O,
collision
nie tak
domains.
będzie tutaj opisane.
Any area in your network where a collision could occur and you need CSMA/CD to bail you out is a collision domain. Now, hubs create one big, massive collision domain, and switches create many small collision domains, generally one per physical interface.
Tak, to jest akurat bardzo fajny rysunek będzie, który to opisuję. Czyli tam, gdzie sygnał jest rozsyłany, mogą być kolizje. Huby akurat są bardzo niedobre pod tym względem, bo jeżeli będziemy robić sieć, która ma mieć jakiś redundancy, czyli zabezpieczenia przed tym, że na przykład jeden kabel zostaje zniszczony, mamy problem. Huby tutaj zaczynają między sobą wysyłać wszystkie wiadomości i będzie cały czas jakaś kolizja. Co nie jest ani troszkę fajne. Za to bridge już prędzej, ale no dalej też nie. Ale switche najlepiej. Także switche troszeczkę huby są mądrzejsze. Minimalnie. Więc no. Any... O kurde, ja zapomniałem używać kolorków. CMA, CSMA. Zapomniałem użyć kolor. Niedobrze. Bardzo niedobrze. Vision domain. Muszę sobie cofnąć i zrobić klika. Perfect. CD. Rich. Rich Basics to będzie ten inny kolor. Gdzie jest Kurde, jakbym miał też czasem chętnie z tego. No bo to mi zaczął grać nawet dzisiaj, ale nie wątpię. Dzisiaj chcę troszkę posiedzieć nad tym. I to bardziej, bo jak jestem. Jej. Kończy. Domain. Naprawdę wydaje mi się, że chyba to pióro już będzie za niedługo. Ale nie, raczej na łódź trzeba będzie kupić jakiś do niego. Ale co zrobię? Dobrze się słucha.
So if we plot a little network out here, where we're going to have
O,
a router
kolejny
just to break
rysuneczek.
everything up, and on the left side, we're going to have a hub and two PCs. And on the right side, we're going to have a switch and two PCs. Jumping the
Okay.
gun a bit, but that's the switch. Now, this is where the collision domains will be. Hubs create one massive collision domain. Switches create one per interface. And the thing about the switches one is it's actually beneficial to us. The reason being, in the hub's collision domain here, if a collision occurs on this cable over here, this computer and that interface of the router have to take part in CSMA/CD, despite the fact that they were nowhere near the collision. So they have to
Oh,
suffer
no,
even though there was a
there's-
collision on another interface.
Czereczki.
Whereas over here, with the switch, if a collision occurred there, between the switch and the PC, that PC and that switch's interface over there have to do CSMA/CD. This interface and connection to the router can carry on as per normal. This interface and that computer can carry on as per normal. This is one of the benefits of a switch. Having many smaller collision domains makes sense. If this was, for example, different cities or villages, towns, whatever, having an accident in one town affects other towns. That doesn't make sense. If there's a traffic accident. If there's a traffic accident in that town, why should people in the neighboring towns suffer? Doesn't make sense to me. So this is a better option. This is
Hub,
nicer.
switch, router.
Now, before we
Proszę
get
pamiętać.
into the switches properly, we want to look at MAC addresses as well. We have looked at MAC addresses a couple times already, but let's just make sure we're all clear on exactly what MAC addresses are. And they are a form of physical addressing. MAC addresses, or Media Access Control addresses, are a popular OSI Layer 2 addressing mechanism. They are made up of 48 binary bits, and thankfully we don't have to
Ooh.
memorize those 48 ones and zeros because we'd rather write
Live hexadecimal characters. 8 bitów. No. Czyli to jest 48 przez 8 to jest 6. No, 6. Dobrze mówię, 6 oktetów. Kurde, jednak myślę. Czyli jednak dobrze mówię. Od razu z głowy. Kurde, nice. Czyli media bez control. In short. Nie powiedziałbym popularne, chyba one są najbardziej stosowane w ogóle tak naprawdę. Nie widziałem na ten moment po prostu żadnego zastosowania innego, by identyfikować urządzenia sieciowe oprócz IP. IP wiadomo, jest bardziej przyjemne, łatwiejsze troszkę do zrozumienia. Maki dalej chyba są jedyny sposób na takie bardzo mocną identyfikację urządzeń. Oprócz, że możesz MAC adres spoofing istnieje, czy podmienianie maków na karcie sieciowej, chociaż bardziej. Wydaje mi się, że to zależy wtedy od po co to robisz, bo da się to zrobić. Znaczy to robią w gierkach, żeby ominąć sobie po prostu bany. I specjalnie nie kupować po prostu kolejnej karty sieciowej albo no troszkę takie mm, dziwne. Ty masz adres. Bardzo dziwne. Chociaż ludzie zrobią wszystko
12
naprawdę.
hexadecimal characters. And they are built into your network card. They are literally etched into the chips of the network card controller circuit. So they are part of the network card. The only way you're going to get a real new one is by getting a new network card. Now, you might have come across this thing called MAC address spoofing. And if you're working with Windows 10 or 11, you might have seen that when you connect your computer to a guest wireless, Windows offers you the ability to randomize your MAC address for security. That is called MAC address spoofing. And it is a way to tell your computer to lie about its MAC address. Just before the traffic leaves the network card, a piece of software running on the computer intercepts that and removes the real source MAC address from the frame and puts a fake one in there, tricking the network into thinking, oh, that's actually what your MAC address is. Now, it doesn't actually change what your MAC address is. It just changes what the rest of the network thinks it is. It's sort of like if somebody gives you a fake phone number instead of their real phone number.
Tylko
You won't
zakładasz
know it's
maskę.
fake until you try and call them.
Mówisz, że
Guys,
jesteś
if you
kimś
don't know
innym.
what this is about, ask the ladies, they'll tell you. Sorry, ladies, I just let slip that secret. My bad. Anyway. Now, the interesting thing about MAC addresses is they're pretty guaranteed to be unique. But the problem is, even though they're unique, they are not predictable, which is why we only really use them for LAN communications and not internet communications. IP addresses are not unique, as you've seen with what we've done previously with the IPv4 videos, the natting, all that good stuff. But with IPv4 addresses, they are predictable. As long as I know what your address is, I'm pretty certain of how I can use that to get traffic to you. Whereas a MAC address, I've got to find out what it is at some point. So let's understand, why are they guaranteed to be unique? Well,
Yeah.
MAC address is broken into two parts.
To
The
jest
first half, the first
prawda.
24 bits or 6
jest
hexadecimal
fajne.
characters, are called the OUI, or Organizational Unique Identifier. And
Czyli
the
każda
manufacturer of a
karta
network card,
sieciowa
or any network appliance for that matter that needs a MAC
musi to
address,
mieć.
has to approach the IANA and a couple of other numbering and naming authorities to get that OUI. So if you go and buy a bunch of network cards from a particular manufacturer, the chance of them having the same OUI is pretty damn high, especially if they're rolled off the same production line at the same time. Now, the reason why I say it's pretty damn high is because a lot of network card and network device manufacturers have several OUIs assigned to them. but they have to use that particular string of 24 bits or 6 hex characters. And the second half goes by a couple different names. I've seen vendor assigned, I've seen interface ID, I personally hate that one. And then the most standard name I've seen is the network interface controller specific portion, which is unique to the network card. And one of the agreements that the manufacturer of the network appliance has to abide by is that they will make sure that they give every network card they produce a unique NIC portion for the given OUI that they were allocated. So if we stick an example MAC address here, 0017C84F30F2, the first half is the OUI, and the second half, the 4F30F2, would be unique to that network card. No other device should have that exact combination of OUI and interface ID. Somebody else could be running around with an OUI of 0017C9 and still use 4F30F2, but it'll be unique still by one digit. But there is a MAC address I know you will have in your network at some point, and that MAC address is called the
Broadcast max address, tak.
It is all binary ones, so it's 48 ones. I'm not typing those all out, sorry, I'm a bit lazy. We can write it with 12 hexadecimal Fs, it's the same thing. And this is a MAC address that we use as a destination MAC address when we want to make sure the traffic goes everywhere. Switchers will see this MAC address and go, okay, I'm going to send this out
I
of
need to send it
every
out.
single
Yep.
interface except the one it arrived on. So when I want to make sure traffic goes to everybody, I use this destination MAC address. So now let's get into the switches proper.
Okej, jeszcze przepiszę na szybciutko, bo to będzie o X decimal. To kot. To kot. Co szukasz? Pikuś. Co jest? Co jest? Niedobrze ci? Nie przeszły drugi korporat, który będzie teraz... A. A. Przed drugi. Znaczy przyszła malutka. Inka. Raz, dwa, trzy. Jeszcze trzy. Dobrze? Tak, trzy. Oj, kurde. Coś co ma, nie wiadomo co. Okay, switch will act like hubs when they see these destination MAC addresses. Tak, bo wiadomo, że po prostu rozesłać wiadomość po całym sieci. Mm. Useful. Useful. O matko, zawsze dwa razy L pisze. Nie wiem po co. When Tak, ale to widzisz
address.
też. Mogą wysłać na wszystkie.
So now
Różnica
let's get
być
into the switch's
problematyczna
properties.
troszeczkę.
So
Okej,
first of all,
następna stronka będzie
let's look at
lepiej.
what we already have. Hubs and bridges. Hubs have loads of interfaces, but they've got absolutely no forwarding intelligence. Then you've got the bridges. They've got forwarding intelligence at layer 2, but they don't have that many interfaces. That's the big downside of bridges. So a bunch of network engineers got clever. They booked a hotel room and put the hub and the switch in that hotel room. And they waited a long while. And then after a long while, out came a switch. So the switch gives us loads of interfaces, and every one of those interfaces has layer 2 forwarding intelligence like a bridge does. Now, the way the switch will keep track of things is it's going to keep track of stuff with a MAC address table. And it's going to associate MAC addresses it learns by looking at source MAC address fields of traffic, just like the bridge did, with the interface that it heard the traffic on. And please be aware that the bridge can associate more than one MAC address with an interface. Looking at the switch over here, it would have learned that PC's MAC address on that interface, and at some point, these two PCs would have sent something to that PC. So that PC's traffic would have arrived there. The switch would have learned it on that interface. That PC would have sent something. It arrived there. The switch would have learned its source MAC address on the same interface. So switches can associate multiple MAC addresses with one interface. Please remember that. It's just like the bridge. The bridge remembered multiple MAC addresses per interface. Why shouldn't the switch?
Tak. Więc jesteśmy w stanie po prostu bez ciężkiego problemu zapisać sobie taką tabeleczkę. Gdzie zapisuję po prostu dla każdego interfejsu wszystkie MAC adresy, które rozpoznał dla nich, czyli będzie tutaj 01, 02, 03, 04, 05, a drugim będzie 01, 02, 03, 04, 05, B, B, C, C, 02, 03, 04, 05. Tam. Co się dzieje, kurczę? Chodzisz mi tutaj. Musisz o coś. Wiem, o co ci chodzi. Ajajaj. Takim. Tak, adres. I mamy tabliczkę na tę sieć. Fajnie było dobrze zrysować też. Czyli tutaj dajemy peceta. Switcha. Innego, troszkę dalej. Tu. Pecety u niego. Prawda. Czyli fajnie było jeszcze podpisać, że interfejs 0, 1 i mamy rozpiskę małą, mały diagram.
There's a bit more to switch logic that I want to teach you about, such as switches will inspect the source MAC address of traffic arriving all the time. And what it does is if the MAC address is new, it adds it to the MAC address table associated to that interface. If the MAC address is not new, it moves on to a forwarding decision. So the switches are always looking to learn, whether it's been running for 5 minutes, 5 hours, or 5 years. It will always want to check and see if it learns anything new. Then the switch will check the destination MAC address of the frame that arrived. If the destination MAC address is present in the MAC address table, the switch will only forward out of the interface that is associated with that MAC address. If the destination MAC address is not present, the switch does what's called a flood operation. It'll send it out of every interface except the one it came in on. This is usually done in the early stages of a switch starting up, when the MAC address table is still empty. The MAC address table resides in the switch's RAM and is never saved to permanent non-volatile storage. So power cycles, power trips, physical resets will clear the MAC address table. So when the switch doesn't know, it sends it out everywhere.
Tak. I to jest akurat, co być problematyczne w switchach. Znaczy, fajnie, że się uczą i są w stanie po prostu zapamiętywać adresy MAC w swoich tablach i jest to coś, co jest praktycznie bardzo łatwe do zmienienia, bo są w ramie i nie... No. Po prostu nadpisywać, albo zmieniać, albo zapominać. Broadcastowanie jest nie najlepsze. Za dużo broadcastów i może się zrobić lupik. O, zrobiliśmy troszkę inną sieć, zrobiliśmy sieć bardziej odporną na zniszczenie kabli. Nie. Recording. O, muszę po prostu gdzieś wysłać. Jeszcze co? Switch. Inspect. A. Inspect the freaking Cisco. O, co ja dopowiadam cały czas, że nie, czy on sobie wybierał. Okej. Poszło.
In the hope that it gets the traffic to the intended destination, and the destination generally would reply. A lot of the upper layer protocols that we're going to get into in a later video, but I did allude to them in the TCP/IP video, are going to have some sort of response from the recipient. So the switch is banking on that to see that MAC address coming back at some point. So it learns it and can use it in the future and then do the more precise forwarding operation. Then the other situation is if the destination MAC address is the layer 2 broadcast address of 12 hexadecimal Fs. It floods it out of all interfaces except the one it came in on straight away. It's not intending to learn with a broadcast. The reason being, the switch can tell when that's the destination MAC address, the sender of that traffic wants it to get everywhere. So let's have an example. Got a nice little simple network here with a switch in the middle. It's got interfaces 01, 02, 03. We've got PCA, PCB, and PCC. A has got the IP address of 192.168.0.1, MAC address 01.02.03.04.05 AA. B's got the IP address of 192.168.0.2, MAC address of B, and C has the IP address of 192.168.0.3, and the MAC address of blah 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 CC. And on PCA, the user types in to their command line ping 192.168.0.2. Now ping is just a simple layer 3 hello message. It sends a layer 3 message to the destination IP address and expects to get a simple hello back. Just checks basic connectivity. So PCA starts constructing this ping packet. It will populate the 4 key addresses, destination MAC, source MAC,
Bardzo to fajnie widać
source
na
IP,
przykład
destination
na
IP with
Cisco.
what it believes to be the best information. And
Jak
obviously it starts out
rozpisce po
with
prostu
source
tej sieci.
information because obviously
Więc
source information belongs to PCA.
szczerze tego nie będę
Source
robił,
MAC address is
że
0102030405
później będą projekty
Source IP is
sieci, ale to
192.168.0.1.
będą na
Destination
Cisco.
IP, we get it from the ping command, 192.168.0.2. Destination MAC address. The PCA hasn't spoken to the destination. It's going to have a bit of a problem. Because what it does is it checks something that's got called the ARP table. The ARP table is the address resolution protocol table, and it keeps track of known IP addresses and MAC address associations. So in other words, what MAC address is this person using? And like I said, if A has not spoken to B before, this table is empty. Doesn't know anything. So this ping packet is not going to work for now. Oh dear, dear, dear. So we're going to get rid of it for now. And we're going to introduce something that will allow A to find B's MAC address without knowing it at all. We're going to generate what's called an ARP request. Very similar fields. Source MAC 0102030405 AA, PCAs. Source IP 192.168.0.1, A's. 192.168.0.2, the person we're looking for. Courtesy of the ping command.
Bo mamy
But this time we
destination
put
MAC
the broadcast
jako
MAC address
broadcast.
as the destination MAC address. And the ARP request is basically a message saying, hey, whoever's got this IP address, please reply to me.
Yep.
I want to know what your MAC address is. So this broadcast now leaves the PC and arrives on the switch on interface 01. Now the switch has got an opportunity to start populating its MAC address table. So in this MAC address table, it's keeping track of its interfaces 01, 02, 03. And it goes, ooh, I've just received something new. And it's checked source MAC address 01, 02, 03, 04, 05, AA. Nope, don't know that one. So let me put it over here so that I now have it for future reference. Now let me check the destination MAC address. Oh, it's the layer 2 broadcast. Oh well, no point me checking the MAC address table, says the switch. Let me send that out of all of my interfaces so that it gets to everybody. Now that it goes out to everybody, let's just get C out of the way. C will check this and realize it's not meant for it. C will see, okay, the person that they're looking for is 192.168.0.2. I am 192.168.0.3. It's not me. So it ignores this. But PCB will see it. PCB will say, okay, somebody with this MAC address and IP address is looking for this IP address. Ooh, that's my IP address. And it's an ARP request. They want to know what my MAC address is. So B says, all right, I better reply to this person. Now, B, being clever, will take this opportunity to populate its ARP table so that it knows, okay, that IP address is associated with that MAC address. And then it starts crafting an ARP response. B will put in its ARP
Jest to
response,
bardzo
its MAC address for the source
fajne.
MAC, its IP address for the source IP. Remember, this is a
Dobra,
response
spoko.
from B to A.
Akurat.
A's IP address is the destination. And remember, it takes that request's source MAC address as a way to populate the destination MAC address for the response. It's there in the ARP table as well now. So now, PCB can send its response. That response now arrives on the switch. The switch goes, ooh, I just received something on interface 02. Let me check. Do I know that source MAC address? 01, 02, 03, 04, 05, BB. No, I don't know it. So the switch
O matko.
goes and puts
Pierwszy raz
that
widzę,
in the
że
MAC address
mi...
table
Oj,
associated with interface 02.
łączyć
Then
kabel.
the switch goes and checks
Łączyć.
destination MAC address of this frame 01, 02, 03,
Chyba
04, 05, AA.
mało mocy
It
leci
says,
na
yeah, I've got a record there.
telefon.
And if I send it out of interface 01, it should get to the recipient.
Zapomnieć go.
So let me do that, says the switch.
No
And
jest jak
out it
źle.
goes. Now, PCA receives that ARP response and goes, ooh, that person I was looking for has replied. Now I can see what their MAC address is. And PCA can now put that record in its MAC address table. Now that the original PC has learned the MAC address of 192.168.0.2, it says, okay, now I can get that ping packet back, and this time I can now put the destination MAC address in the DMAC field. 01, 02, 03, 04, 05, BB.
Bardzo długie wytłumaczenie tego, naprawdę.
PC can
Ale
at long last send the
czasami o
ping.
tym się zapomina.
The ping
Całkowicie.
arrives on the switch on interface 01. Obviously, the switch doesn't know it's a ping, it doesn't care, it just sees MAC addresses. And it says, ooh, I've seen this MAC address before, so I don't have to worry about it. And it's going to this MAC address, and I've got that MAC address there. So let me send it out of that interface. So it's going to go out there now to PCB. And by the way, this example didn't just teach you how the switch works and how the traffic's going to end up going around, although it did actually. But I also
Yep.
taught you how the address resolution protocol works.
ARP,
This
no.
runs always when you don't know the recipient's MAC address. This is how we can find out what the MAC address is despite it not being predictable.
ARP jest
We
bardzo fajny.
ask. And the way we ask is by yelling out to everybody in the LAN, hey, who is responsible for this
To-
IP address? I want to know what your MAC address is.
odpowiedzieć
That is
mi,
basically
no.
what ARP does. It goes and finds out what the unknown MAC address is with a known IP address. Now, in this case, we knew what the IP address was because of the ping packet. In other situations, we might have used a host name or something like that, and some name resolution service like DNS would have given us the IP address, and then ARP takes over once we've got the known IP address. So now let's move on and look at a couple different types of switches you can get. The first major category you want to be aware of are managed and unmanaged switches. Now, the key thing about a managed switch is this is the kind of switch that you can log into and configure things on it. Whereas an unmanaged switch, it's a simple switch. You plug it in, you cable it up, and it does its thing. Both switches will ultimately do the same stuff we've just looked at. But a managed switch gives you access to a bunch of cool configurations and settings that we're going to look at with some later videos on more advanced switch features. So how do you tell them apart? Well, on the left there, you've got a managed switch, and on the right there, you've got an unmanaged switch. And the way I know that the one on the left is a managed switch is that little interface there I've circled in red. Now, I tried zooming in on this picture, and sadly you can't see the writing, so you have to take my word on it. But that interface that's circled in red is labeled console. As soon as you see an interface labeled console or con0, that implies that is the interface that you plug into to apply configuration. You'll use one of those RS232 to RJ45 console cables, or one of those rollover cables we spoke about in the cabling and connectors video to apply your config. Now don't worry, if you've got an unmanaged switch, it's just as good as a managed switch. The only difference is you can't choose any settings. But if you've deployed a managed switch and never ever applied a setting to it, it's fine. You cable it up, it does the basic switching like an unmanaged switch does. You don't have to go and turn anything on. But believe you me, in an enterprise environment, the settings and features that a managed switch brings to the table are well worth it. Then we get desktop or small office home office switches versus enterprise switches. Now, desktop switches are usually quite small, compact, run from one of those little DC power bricks or woolworts, as some people call them, and usually have a couple
A small office,
interfaces, very
home
rarely more
office.
than 8 or 10 interfaces. They're often also going to be a nice shape that's easy to have in the home environment. It's not bulky, it's not heavy, it's easy to put out the way. I've actually got one screwed to the back of my desk as part of cable management, just so that I can connect a bunch of things that I've got sitting near me right now. Then you get enterprise switches, bit bulkier, normally loads more interfaces, but the key thing about enterprise switches is they come in rack unit form factors. Usually, most switches like this one in the picture here are 1 rack unit high, and you can put them in a network cabinet, server rack, whatever, because again, that one in the picture there is probably the 19 inches wide it needs to be to fit in a networking cabinet. You sometimes do get slightly smaller enterprise switches that aren't 19 inches wide, but they will normally come with very long armed brackets so you can mount
Okej.
them in a networking
Tak.
cabinet or server
Eee,
rack. Now, yeah,
Jest to wielkość procesora. Tak bym poszukał. O. O, tak wyglądają. I dosłownie są wielkości jednego. O, tutaj. Jest wielkość jednego. Dosłownie to są takie szafki komputerowe. Bardzo fajne. Widziałem je, bardzo przyjemne, bardzo fajne. Jest jakieś urządzenie. Rzęd 10. Oj, co jest chyba... Na dyski? Tak, na dyski. Gdzieś. To jest całe chłodzenie z tyłu. Dyski. No cóż.
yes, I did reuse the managed switch picture, but an unmanaged switch can
Spoko,
also
miłego,
be in an
papa.
enterprise form factor too. Then the next type you get are fixed and chassis switches. Fixed switches, like the unmanaged switch or the managed switch that we looked at previously, have a fixed number of interfaces. You can't change them. It is what it is. You get what you get. If you wanted more interfaces, you should have bought the one with more interfaces. If you've got too many interfaces, you should have bought the one with fewer interfaces. Yeah, no, it's a bit brutal, right? But then you get that very elegant, cool looking chassis switch over there. What's going on there? Well, that still mounts in network cabinets, assuming you can find one big enough for that bad boy, and obviously server racks. And what happens is all of those interfaces there are removable cards. You can take it out and put maybe a better processing unit in or another fabric unit. It allows you to decide how many interfaces, what kinds of interfaces, and how much processing power the switch is going to have. Now, this is not your average kind of user LAN switch. This is the kind of thing you'll find in data centers and cloud provider environments and ISP networks and stuff like that. These are pretty badass switches. They're really cool. And they also have redundant power supplies as well, because I mean, when you got this level of coolness, you don't want something as simple as a faulty power supply taking it down. And they are very expensive. I'll let you go do some homework on how much they cost. Just make sure you're sitting down when you check what the price is. And then you're going to come across this thing called a stackable switch. And that's what it looks like. Huh? That just looks like a bunch of switches cabled together. Normally. Why is it stackable? Well, switch stacking is going to use a special kind of cable. And what it does is it allows you to get multiple switches, usually manageable, to work together as though they were a single logical switch. It's a pretty cool technique, but in my opinion, you don't need to know much more other than that's what it is for Network Plus, because you are going to want to try and stick to the same vendor, preferably the same model of switch if you're going to do stacking. And the reason why you want to do this is so that you can expand on connectivity and processing capability without having to go through the expense and challenges of getting a chassis switch. Because in some cases, even the smallest chassis switch is overkill for what you need. Now, knowing me, I'm going to find a way to tell you more about stackable switches later on because I really dig networking and I want you guys to be kick-ass at it. But before we do that, we need to draw a line for this video. And as far as I'm concerned, that's enough for the basics of switching for now. But don't you worry, we're going to come back to switches more often with some of the more advanced features. We'll talk about things like VLANs, spanning tree protocol, and some other cool things. But for now, I want to say thank you for watching.
STP jest bardzo
If you
fajne
enjoyed
też.
this and you
Na STP. Spanning protokół jest rozwiązaniem kilku problemów. Tam. Jest open source też. Jest rozwiązaniem też, że nie jest jakieś proprietary typu jak Cisco ma swoje bardzo dużo różnych. Urządzenia Cisco tylko i wyłącznie mają to jakieś feature'y. Więc to jest też fajne. Nie musisz się tylko robić Cisco i koniec. Innego urządzenia nigdy nie dotkniesz, chociaż Cisco mam dość dobre to urządzenie. No cóż. Są... SPF Android jest... No. Bo SPF jest chyba... Czyli tam chyba po prostu mają zupełnie inny problem.
hello there.
Może spójrz na Udemy jakiś kursik. Ojejku, wilany. Ojejku, to jest dopiero w ogóle ciekawego. Podstawy trunking tam będzie też. Wilany też są fajne i przyjemne do używania. I nawet bardzo potrzebne. Rozdzielanie sieci pomiędzy switchami.
Let's start doing some advanced switch things, like VLANs or virtual LANs. But before we get carried
To jest
away
takie
with
bardzo
VLANs, let's talk
zaawansowane.
about broadcasts because they're the blessing and scourge of LANs and one of the
No
main
właśnie.
reasons why VLANs exist. So first of all, we need to
No niebiesko
understand
miał
what
być.
is a broadcast
Aj,
domain.
uwaną się,
A
uwaną się,
broadcast domain
ułamiała.
will be any
Miał
body
być
in a
niebieski
network where a layer 2
rozszerzący
broadcast
frypalec.
will propagate. Remember?
I to będą tak. VLAN. I ponownie trzeba meteczka. Testy razy niebieską. Czy niebieską widać? Nie widać. Aha. Nie widać. No cóż. Okej. Sobie to. Wpisać VLAN. Okej. Oj. Teraz. Przestaniemy sobie troszkę. OK, git. I mamy coś takiego broadcast domain, który. I to jest to, co. O czym troszkę powiedziałem wcześniej. Czyli broadcasty. Jak one są w stanie. To będzie mówione, jak będą w stanie. Wychodzi, zaczyna zapętlać sieć. Bądź po prostu kółeczka w sieci. STP to całkowicie wywala, bo blokuje. Znaczy, blokuje. Nie powiedziałbym, że blokuje, tylko stopuje. przesył danych pomiędzy liniami, które są redundant, czyli mamy główną głowę, która zarządza całą tą siecią i ona po prostu mówi, jak dojść z jakiego switcha gdzie więcej. Tylko że to ma wiele minus, że to nie jest rozwiązane na bardzo sieci. USCP jest fajne, ale na bardzo duże sieci będzie zbyt obciążający, bo jeden switch będzie musiał być po wszystkim. Nie będzie rozdzielać po prostu sieci. Czyli mamy wtedy do jednego switcha, który jest połączony do każdego innego. Po prostu. Każdy inny będzie, jeżeli chcemy mieć redundant, czyli chcemy mieć linię pomiędzy, będzie blokować te dodatkowe, ale wiadomo. Jest bardzo zależne też od środkowego. Jak padnie, to mamy problem. Odszukujemy kolejny. Sieć zwalnia. Topologia sieci całkowicie się zmienia na ten czas. Później trzeba znowu ponownie to ustawiać. Albo ręcznie, albo automatycznie. Automatycznie też nie jest najlepszym pomysłem. Lepiej jest wszystko ręcznie zrobić. Ale cóż, dobra. Ale i co Milany? Eny. Eny. Inlan. Wow. Dawaj. Podcast.
The broadcasts we discussed in previous videos are going to have a destination MAC address of all hexadecimal Fs or 48 binary ones if you prefer the binary. And when a switch sees this, the switch will flood the broadcast out of all of its interfaces, apart from the one it came in on. And that's under normal circumstances. Also, bear in mind that a switch has got no way of knowing at the moment, until we start doing VLANs, where a broadcast belongs, who it's meant to go to, stuff like that. It just follows the very simple instruction, everyone must get this message.
Kropeczki. Rozumiem chłopa, ale też piszę. To bym to
The good news, though,
zdawać za chwilę. No,
is routers.
tak, routery już mają są dużo lepsze pod tym względem, bo one będą blokować i będą pamiętać, one będą więcej rzeczy robić i problem z używania routerów w takich sieciach to jest hej, router więcej kosztuje. Hihi. I routery mają na pewno nie tyle interfejsów, ile potrzeba. Dobra. Switch will flood a broadcast out of all interfaces except the one it came on under normal circumstances. Tak. Normal, czyli jak zawsze jest jakieś ale. Jest...
or any layer 3
No
gateway
i
for that
teraz
matter,
pokazywać
are going to break
diagram
up our
znowu? Chyba
broadcast
tak.
domains. So
Pamiętam.
let's see one in action with that topology
No.
from our switch
To jest
video.
dosłownie... To jest
So we've got a router in the
topologia.
middle, we've got a hub on the left, we've got a switch on the right. And broadcast domains are very easy. Everyone's part of a broadcast domain. The only thing that breaks up the broadcast domain at the moment is the router. Now, hubs naturally broadcast just because they're layer 1 and they relay a signal out of all interfaces. And the switch, it will forward a broadcast if the destination MAC address is all Fs, or a unicast if the switch does not know the destination MAC address. Now, if you watched the previous video on the switches, you might be thinking, but wouldn't ARP have already found the destination MAC address and caused the switch to learn it? Yes, it would have. But if the switch was power cycled, the MAC address table will be flushed and empty, whereas the client's ARP tables will still be populated, especially if they're laptops. They wouldn't experience a power outage for a moment.
Mhm.
So there is possibilities where the switch might not know the destination MAC address, but in some way the clients do. Now, why is this such a problem? I mean, this network's pretty small and simple. Well, that's it. This network's small and simple. Let's scale this up a little bit. So we've got several switches and a
Okay.
router acts as a gateway for this LAN segment.
To nie będzie
But
wysyłał.
for whatever reason, we've decided to put 4 different departments on this set of switches. Now, the problem is, if the computer in department A over there sends a broadcast,
Tego nie będę
it will hit that
przesywał, bo to
switch.
jest masakra.
That switch will then propagate it out of all interfaces, including to people who are not in department A. That broadcast hits that core switch
Broadcast
in the
leci
middle, and guess
momentalnie
what?
do
It
core
also goes
switcha
out of
i
all
wychodzi do
interfaces.
wszystkich i
Now the router's
przez
going to probably
wszystkie.
ignore it because it's going, oh, layer 2 broadcast not meant for me. But the other switches, they are going to do what switches do, which is forwarding the broadcast. So it's going to go out of all those interfaces to all those computers. And chances are that person who sent that broadcast probably just intended, or if they didn't do it, the software on their computer did, it probably just intended for that traffic to only go to people in department A, not B, C, and D. So this is a visual of the problem, but there are a couple of other ones as well. So what are they? So as we saw, it creates a lot of unnecessary traffic, which is going to be a waste of bandwidth, obviously. And is also going to be a waste of time for the recipients processing that traffic that is never going to be meant for them. But there's also a bit of security risk as well. There is the possibility that somebody in a different department could do a packet capture. I know I would. And there's also going to be greater visibility if an attacker has a rogue device in there for them to do reconnaissance.
Zabezpieczenia. Kurde, trzeba będzie się nauczyć. Drugi temat to będzie o to zabezpieczenia, żeby się poduczyć. Do tych sieciowych rzeczy. Bo tak. Te sieciowe rzeczy też będą bardzo pożyteczne. Accessing the security re... Visibility. Matko, ja teraz brzydko napisałem to. Nasze tutaj stany dzięki zapisku i... Kurwa. No cóż, reszta wygląda nawet ok do czytania. Więc nie jest źle. Co nie jest źle. Dalsza część.
And then, malware generally has a much easier time spreading when everybody is on the same layer 2 network. If we can break it up into separate IP subnets, we can have a much easier time with keeping that malware isolated and contained. No guarantee, but we're going to have an easier time of it. And in general, we're going to have challenges making our network more optimal, because it's going to be harder to prioritize traffic when everybody is in the same IP subnet or common layer 2 network. So let's go and use VLANs to fix this. So the basics of VLANs. First of all, a virtual LAN, or virtual local area network. We love our acronyms in networking. First of all, a fix this subnet or common.
Dobra. Two networks. Oczywiście chyba bardzo szybko to tłumaczę. Ja chcę sobie to zapisać ładnie. Minimization. O. Mhm.
Layer 2 network.
I teraz
So
akwilamy.
let's go and use VLANs to fix this. So the basics of VLANs. First of all, a virtual LAN, or virtual local area network. We love our acronyms in networking. Allows for a logical switch topology to exist on top of a physical one and have different ways for traffic to forward through it. Now, you can also have multiple virtual topologies on top of that one physical topology, which is why we say VLANs plural. And the logical topology can separate devices from one another. So let's visualize this. Scaling down that problem we had earlier, we're going to have a couple of
Ojejku.
switches. So let's visualize
Chcę
this.
sobie to zrobić tylko ten. Logical switch. Yy. Czy to był? Mhm. Masło maślane. No cóż. Ludzi. Se- Halo. O właśnie, jedna rzecz chcę sprawdzić. Troszeczkę jestem ciekawy. Mhm. Jedną rzecz będę musiał zrobić, więc część to jest ten. Hit. O, to łatwiej. Tak, będzie łatwiej. Gdzie to jest? O matko, jedyna znaleźć. Nie. To jest. Okej, czy to ta informacja? Okej, dobra. Ja będę musiał iść, będę musiał ogarnąć.
Hello there. Hello there. Separation like we did
Oh no, I clicked. Oh no, I click back.
physically with that router without having to recable that network. Now let's go and get some terminology dealt with and then we'll jump in. First up is 802.
O matko, to już będą te standardy? Mhm. Yep. Zaczyna się. No nie. Mm. I, 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 802, 802, 1, Q. Czyli Q amendment. Troszkę późny.
.1q. That is the IEEE standard, and it's an open standard implementation for VLANs that all
I to każde urządzenie Switch będzie mógł używać.
enterprise, and small business network vendors will support. You may come across some vendors and their proprietary implementations of VLANs, which is all well and good, but now you're bound to using that vendor for all of your switches, at least for that LAN segment. Might be better to go with 802.1q. It gives you a little bit more mobility and helps avoid vendor lock-in, which is something you want to consider with enterprise networking. As wonderful as a given vendor might be at the moment, they might
Nie
not be as
oznacza, że
great in the
będzie
future.
fajnie.
Remember, companies are
Już
not
nie,
your friends.
tak.
They're in the game to make money. We're also going to talk about untagged traffic. Now, we're going to get into it properly, but what's going to happen is VLANs and our switches are going to impose something called a VLAN tag, which allows the switches to know which VLAN traffic is associated with. And if traffic has got no VLAN tag, we call it untagged traffic, and it's basically just an ordinary Ethernet frame. But when we do put a tag on it, we refer to it as tagged traffic. Now, in addition to this, we're also going to talk about these things called access ports. These will be switch ports that will be sending and receiving untagged traffic. I'll explain where they are and what they're about when we're doing a diagram. And then we have trunk ports. Sometimes you might see them called tagged ports, but it's the same thing if that's the name being used. And these switch ports
Transport dorzucił w następnym filmiku, proszę pana, tam jest pod następnej sekcji, trzeba będzie to oglądnąć, że się cofnąć do wcześniej, do tej, kontynuować, bo totalnie zapomniałem powiedzieć o trankach. Tranki pozwalają na przesył wiadomości pomiędzy innymi filanami. Nie, gdzie mu powiedziałem, że to jest chyba to może pomiędzy było zastosować, żeby po prostu wejść do innego filana. Przypomnieć sobie. Target jest trafik. W momencie, w którym mamy Ethernet frame'ów w Ethernet. Jest 1Q tag. Access. Tak. Ja nienawidzę CI. Pisać receives. Receives. Zawsze to piszę źle. Cóż, jestem bałwanem pod tym względem, ale co zrobię, nic nie zrobię.
will be able to send and receive tagged
I
traffic.
teraz będzie dużo rysunków.
Now, with all that in
Oczywiście.
place, let's go check out how VLANs are going to help us out. So we move that topology over a little bit, so I've got space on the left there to write stuff. And the first thing you would go and do is you would go and create the VLANs. Shock and horror, right? Now, once you have decided to do that, you're going to be doing this on each of your switches. And when we are making our VLANs, we're doing it by number. So I will be running commands or clicking on console options in a web console that will say VLAN 10, VLAN 37, VLAN 42, whatever. We make and identify them by numbers, not by names. So we're going to have VLAN 10, 20, and 30 here.
Najlepszy
For no other
sposób
reason than this is just a
pisania.
bit of a habit for me.
Tak.
But one of the reasons why I like to do 10, 20, and 30 is maybe I want to create some special VLANs for Department A. So I can use everything from 11 through to 19 and think, oh, that's part of Department A. And 21 through to 29 for special things for Department B. So I do like to space my VLANs out a little bit. But you do you, or follow the best practice that your workplace is using. Now, you can create up to 4,096 VLANs. So you've got quite a bit of room to play there. You can get more.
Jest bardzo dużo miejsca na to, żeby po prostu zrobić bez żadnego problemu. To jest akurat fajne. Ja PC teraz sobie kolorystycznie, naprawdę. Różnymi kolorkami. Po to, żeby tę sytuację nakreślić. Sobie pamiętać. Okej, jeszcze może niebieski kolor na było. Tak. Sobie zapiszę z boku, czyli tak i 10. Zielony będzie VLAN 20. I VLAN 30. Departamenty tak naprawdę nie są potrzebne, nic totalnie. Po prostu OK, jest widoczne. Czyli tak, we are creating VLANs. Yeah, numbers. Up to 4096. Dość dużo. 4096. O matko, ale się zrobił Blu-ray. Para troszeczkę kalkuluję, jeżeli... O, fokusuję na palcach. Dobra, fokus po prostu. Łapię różne rzeczy. Right. Nice. Revolution.
More, but for now, we're just doing normal VLANs.
Sure.
And a special thing to understand is VLAN 1 exists by default. If a switch supports VLANs, VLAN 1 will exist by default, and all interfaces will be access ports for VLAN 1, which once we've looked at what access ports are all about, you'll understand then that basically that particular default status or configuration, if you want to consider it a configuration, is going to effectively negate the presence of the VLANs. So let's assume I've run through all four of those switches and I've created VLANs 10, 20, and 30. Now, next thing I'm going to want to do is I'm going to want to go create my access ports. Now, my access ports are going to be the interfaces I want to use to connect my end devices to the infrastructure. So let's go make all of those connections to those PCs to be access ports. And what access ports will do for me is they will be receiving untagged traffic from that end device, because obviously I don't expect these client computers to understand 802.1q or VLANs. And those access ports will be adding a VLAN tag to that traffic so that it can be associated with that VLAN. Now that means I'm going to have to make these access ports members of those VLANs. And then when it comes to sending out traffic, the access ports will remove the VLAN tag before it sends the traffic out to the end device. As I said a moment ago, we do need to make sure these access ports are members of those VLANs. As I said a moment ago, tag before it sends
Dobra, bo tu jest naprawdę dużo wiedzy. Sportu. Receive untagged. Frames. Device. Device. Z tego powodu usuwa, żeby po prostu te komputery ogarniały to. Są tutaj. I one będą dawać tym wysłanym pingom, czymkolwiek po prostu tagi danowe. Już pamiętam wtedy
the traffic out to
sam
the
router
device.
też to usuwa.
As I said a moment ago, we do need to make sure these access ports are members of those VLANs. So let's quickly mark each access point with which VLAN it's part of. So we've got those two access ports being part of VLAN 10. We've got that access port being 20, that one being 30, that one being 20, and that one being 30. Great. So this is going to start separating these 6 PCs into the 3 different departments now. Good stuff. Now let's have a little mini transmission taking place. Let's say we have that computer there sending a broadcast. That traffic will travel untagged to the switch. When it arrives on the switch will add a tag or a label that says this belongs to VLAN 10. The switch will then check, do I have any access ports that are part of VLAN 10 if it's a broadcast? And will say, yes, I do. Let me send that traffic out. But remember, when it goes out of that interface, it's got to go out untagged because most computers don't understand VLAN tags. So they would think that extra data is corruption or some crazy weird stuff that they don't know how to deal with. But that worked out nicely because both people that are in Department A are on the same switch. What about when people that are in the same VLAN are on different switches? Well, we have to do something a little bit cooler there. And that thing is setting up some trunk ports between the devices. So trunk ports will be set up between the switches on both ends. So on either end of a cable, I need to make sure that each switch has got the port set up as trunk ports. Cool. Now the trunk ports are going to carry all specified VLAN traffic that has been tagged already by an access port as it arrived. Now I emphasize the word specified because with a lot of the enterprise vendors that I dealt with, you have the option to be selective about which VLANs are allowed to travel across the trunk port.
Tak, setup trunk ports. Jeszcze. Ja nie pamiętam, czy nie trzeba było wejść tutaj. Ten
Hello there.
drugi.
I promise you're not having deja vu. We have done VLANs already, but I need to tell you a little bit more about the trunk ports. Yes, I forgot to include this in Module 12. So consider this Module 12.5, where we're going to talk about what makes a VLAN trunk port work properly. So picking up from a point in Module 12, where we
O,
spoke
11:35. O, kurde. No.
about setting up the trunk ports, and that trunk ports will carry all specified VLAN traffic that has already been tagged. Well, for the trunk ports to do this, they're going to have a VLAN that they are a member of. This VLAN is either going to be called the native VLAN, the default VLAN, or the designated VLAN, depending on which network vendor you're talking about.
Ale fajnie, nawet trafiłem w miejsce, którym miałem to oglądać. Dajsik. I teraz mogę to dopisywać dalej. Trunk ports have a VLAN. Relative. Designate. Dobrze.
But its goal is to carry the other VLAN traffic. So when traffic arrives on those access switches and those access ports apply a tag, that traffic travels across the trunk port with its tag or label on it. Now, for that to happen, this default VLAN that we use between the trunk ports, or this native VLAN, whichever term you prefer, is going to be the thing that carries that traffic. So you can consider it some sort of transport VLAN. Now, the traffic on the trunks VLAN can travel through it untagged, and any untagged traffic that travels through a trunk is assumed to belong to this. So if I were to make those trunk ports use VLAN 5, for example, any traffic for VLAN 5 actually is allowed to travel across the trunk port without a tag on it. And when it gets to the other side, that trunk port will assume that traffic belongs to VLAN 5. But for VLANs 10, 20, and 30, they will have to travel across the trunk port with a tag, which is one of the reasons why we said in the previous video that the traffic will be allowed through if it's specified as an allowed VLAN. Now, to give a bit of an analogy for this, you can consider the trunk port
Ja chcę
VLAN.
to przepisać. Trunk. A trunki robiłem na studiach
Now,
nawet.
to give a bit of an analogy for this, you can consider
Tak, my robiliśmy ten fizycznie. Sieć przed COVID-em jeszcze. I to było fajne, bo dostaliśmy po prostu chyba 5 switchów do podpięcia wszystkich naszych komputerów, żeby po prostu się pobawić i zbyć sobie lana poprawnego. I mieliśmy wykluczać po kolei po prostu osoby, tworząc wilany pomiędzy tym wszystkim. I zadaniem było tak, żeby utworzyć dwa wilany, gdzie komputer 1, 3, chyba 2 i 4 były połączone, a komputer czwartego zawsze mógł dojść jakiś sygnał, czyli czwarty miał być trunkiem. Bo on był podłączony do sieci i zrobiliśmy tak, że na tym komputerze, że po prostu on był, no, niby routerem, czyli on pozwalał nam się połączyć do sieci. A mieliśmy mieć niewidoczny VLAN A i VLAN B. Fajne to było. Fizyczna strona końca zamiast bawić się w Cisco na ten i widzieć tego, co się dzieje. Fajnie to było, tylko szkoda, że no już nie mieliśmy zajęć tak sieciowych na fizycznie, żeby to co ogarniać. Zrobiliśmy wszystko po prostu na Cisco. No i chłop też zwlekał z zadaniem bardzo. Ależ to już totalnie inna sprawa. Bo zadania były też, ale mi się wydaje, że trochę mi też starczy tego, ale kończę sobie mniej więcej ten rozdział. Zobaczymy, co dalej będę robił.
Trunk ports VLAN to work a little bit like this. We're going to have the two switches with trunk ports on each side.
Teraz
Let's say
naprawdę
we've
będzie
got
diagram,
VLAN 10,
tak.
20, 30, 40, 50, and 60. Now, those VLANs will be allowed to travel across the trunk
Tego nie
as
potrzebuję.
long as they are
Bo cały
tagged.
czas to będzie po
But
prostu jeden i
if
ten
I
sam.
set the trunk port to use VLAN 5, it's going to allow VLAN 5 through without its tag. But VLAN 5 is also going to be carrying the traffic for VLAN 10, 20, 30, 40, 50, and 60. It's sort of like saying, okay, if VLANs 10, 20, 30, 40, 50, and 60 are a bunch of cars, and they are currently on the switch on the left there, which is the factory where the car is being made, and we want to move these cars to a dealership. We are not going to drive those cars all the way to the dealership. We're going to put them on the back of a transport truck. That transport truck is like VLAN 5. And when we load all those cars onto the back of the transport truck, those cars are going to be cargo. They're going to be on a shipping manifest. They're going to be listed as something that needs to be shipped from point A to point B. Now, we can comfortably move those cars from the factory to the dealership where they're going to get sold without putting any extra mileage on them. So the new buyer gets to be the first person to put the 100, the first 1,000, the first whatever on the clock. So taking the analogy back to the VLANs, VLANs 10, 20, 30, 40, 50, and 60 are access VLANs that have to travel across tagged, and they will be listed as cargo for VLAN 5, which is going to carry them across this trunk link. Now, I went and specified VLAN 5 as the default or native VLAN for the trunk ports. But if I had not done that, defaults apply. And you'll recall in the previous video, I said that the default VLAN that all interfaces belong to is VLAN 1.
Tak.
So if we don't specify it, VLAN 1 will be the default for the trunk. Now, whether or not that's a good idea for security, I'll leave that up to another course. But let me give you the little short answer there. It's not the greatest thing. It's normally good practice to use any other VLAN besides VLAN 1 for trunk services. But otherwise, that is all I need to tell you about the trunk port and its default native or designated VLAN.
Nice.
Hope you found that useful, and apologies that I didn't include that in the previous video. I don't know why it slipped my mind.
Okay, i teraz będziemy mieć po prostu
Or
dalej
you
tam.
could specify all VLANs are allowed across the trunk port. The option is yours. For now, we'll assume that our trunk ports have been set up to carry all VLANs. I'm not going to start applying restrictions yet. If I've got these trunk ports able to carry all VLAN traffic as long as it's tagged, let's see what happens if we get somebody, let's say in Department C there, this computer, to send a broadcast for Department C's VLAN. So as always, that broadcast travels along, but it's untagged at the moment. Until it arrives on the first switch's
na
access port.
switcha, dostaje tag 30.
When it's on that switch goes, okay, it arrived on an access.
Okej, czyli tak, to się na tag 30. Tag 30 nie jest równy 20. Trunk? Ej, bo jestem w stanie przesyłać, jestem w stanie przesyłać. Wyleci. Ten switch nie ma żadnych VLANów ustawionych, wszędzie ma trunki i rozda się tą wiadomość wszędzie. Poza połączenie, na którym było, czyli poleci na lewo, na prawo. Na lewo switch zauważy, że ej, to jest 30. Elo, mordo, nie mamy tutaj żadnej 30. Prawy zobaczy, że jest do lat 30. Pierwsze połączenie nie jest 30. Koniec. Więc przeleci tylko tutaj.
Access port is part of VLAN
Mimo
30.
tego, że
So let me
tak
label it as
poleci
part
tu,
of VLAN 30.
jeszcze tutaj.
So now that the
Wiadomość.
switch has labeled that stuff as being part of VLAN 30, it will then see, do I have any access ports? Yes, I do. I've got an access port over there, but that access port is part of VLAN 20, not 30. So it's not going to go out there. Then the switch says, do I have any other interfaces that allow VLAN 30? Yes, I do. I have
It's the
this trunk port over here.
Yeah.
So it sends that traffic out of that trunk port, but it travels with its tag so that the next switch that receives that now knows that this thing belongs to VLAN 30. That call switch can now check, okay, do I have any access ports and are they in VLAN 30? Well, that switch doesn't have any access ports. And it does have trunk ports. So it can send that traffic out of those ports. Off it goes. Now I'll show you what we do with the port from the call switch to the router a little bit later on. But for now, the traffic goes to those other two switches that are providing access to the end users. And remember, when it travels out of all those interfaces, it travels the tag for VLAN 30.
Yeah.
Now that traffic has made its way to those switches go and check, okay, it's tagged as being part of VLAN 30. Let's look at the switch over here first, on the left. It says, oh, I've got two access ports, but both of them are in VLAN 10, not VLAN 30. So it's not going out there. Now, let's check out what that switch will do. That switch will see two access ports, but it'll see that one is in VLAN 20. So it's going to say, no, that's not going out there. It sees that access port as part of VLAN 30, so it says, oh, I can work with that one. So then it starts getting ready to send that traffic out. But remember, when it goes out of an access port, the access port's got to take away the tag so that it becomes untagged traffic. And that is how VLANs are able to keep the traffic separated. It looks like it's not going to actually keep that broadcast isolated, but it saves us at the last minute when it says I'm not going out of ports that are not in the associated VLANs. Great. But we've achieved logical separation or isolation, but what about when people in these departments need to actually talk to each other? Well, now we've got to think about doing VLAN routing.
Ojejku, routing. Znowu, ponownie. Czy ja tutaj routing miałem? Tak. Ojejku. Routing jest fajny. It's nice. We like it. We use it. We always. Dobra. Lecimy dalej. VLAN routing.
So let's go through the concepts of VLAN routing quickly. VLANs are logically separated layer 2 networks, and that means we can have different IP subnets being used in those VLANs. Therefore, we need to do routing. Great stuff. Routing between VLANs will either require us to use a router, or we're going to use a layer 3 switch. And I will...
Tak, i naprawdę separujemy tą sieć na mniejszą. Więc usuniemy wtedy z tej części tego cora. Weźmy sobie tego routera, damy go niżej. I dobra, lećmy. Bilans. Zaświeżał ten, że potem sobie z Near to Networks device. Zrobię przerwę od tej nauki. And IP, nie ISP. Dlaczego już robię błędy? Subnet. Service Integrator LAN. Telefon. Wiek znany chyba było 3 sztuki. Nie. Było 11 minut.
We'll get into what is a layer 3 switch just now.
Dobra.
Now, first though, I want to show you VLAN routing via the router. So as we said, each VLAN becomes its own IP subnet. So that
Tak.
means we can have VLAN 10 being 192.168.10.0, VLAN 20 being
Jest. To teraz rozrysować tak, bo to będzie teraz potrzebne ponownie. Tak. Jak dobrze pamiętam, on teraz zmieni też
192.168.20.0 and VLAN 30 being 192.168.30.0.
i z niego
Now
będą
there is
wszystkie
no
inne
need
rzeczy.
to correlate the IP addresses and the VLAN numbers. If you ever do see this done in the real world, it's probably being done to simplify the management or possibly maintain the last shred of sanity for a network engineer.
Ech.
Now, what we could do is we could go and have an access port per VLAN to
Nie,
separate
dlaczego
interfaces
wyszło?
on the router.
Nie.
Like, hello there.
O
Hello
nie.
there.
Dlaczego?
Let's
Cofnąłem
start
sobie aż
doing
tak
some
bardzo.
advanced switch things like VLANs, separate interfaces, a bit better. It's a virtual created the interface, and then the user goes, I've got no config on my physical interface, but I've got these virtual sub interface. The router will then that access switch will
Czy
see
nie
the destination.
ściągnął tego?
So we could do something. It's probably being done to simplify the management
Dobra.
or possibly maintain.
Będziemy opisywać. Dobra, czy jednak bez ściągnięcia tego? A, bo na routerze to nie jest na switchu, który jest routerem. Dobra, nieważne. Czyli tak. Kółeczko ponownie do środka. I do switcha. Samo. Znajdę sam diagram na switch. Ponownie, ale pamięta chociaż. Pam, pa, 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 pa. To tymi samymi kolorami narysuję. Tak, na tym samym narysuję. Będzie nawet wygodniej wtedy. Tak jeszcze. Wiesz, te twoje... Tak, Ilon. 10. Ojej, to miało być 30. Ej, 30. Jest tak. 1, 9, 2, 8, 30, 0. Bardzo fajnie jest opisane. Toczne jest. 2. 8, 0. Które wydane są na której sieci? 10. Dopiszę tam 24. Spiska. Zrobimy to procesy wszędzie. Góry. Potem będę z... Sobie. I okej, lecimy dalej troszeczkę.
And the last shred of sanity for a network engineer. Now, what we could do is we could go and have an access port per VLAN to separate interfaces on the router, like that. There are problems doing it this way, though. Firstly, the router doesn't come with that many interfaces, and if I want to increase that with expansion cards, or WICs, as we call them, WAN interface cards, it can get very expensive to do that, and we do have more than 4,000 VLANs at our disposal. So this method is not going to work out very well for us. So we could do something a bit better, like making that one connection to the router a trunk port. Now, if I do that on the switch side, then I can do something very cool on this router. I can do something called a sub-interface. It's a virtual interface on the router. And as I said, we trunk from the core switch to the router, and we create virtual sub-interfaces on the physical interface that that connection goes to. So whatever that interface is called, I can create sub-interfaces underneath that one. Now, once I've gone and created those sub-interfaces, I can go and give them IP addresses so that those sub-interfaces can act as default gateways. And I will also tell those sub-interfaces to terminate specific VLANs. Now, word of warning here, though, there may be a bit of extra configuration you need to do depending on the network vendor that made the router. But you'll have to check that vendor's documentation, courses, material.
Tak, no oczywiście, jak zawsze, i robi różne standardy, myśli o różnych rozwiązaniach na ten problem. Jej. Wyszło. Virtual subinterface. Through column. Gateway.
Whatever it is that you rely upon to know how to work with that vendor. So let's put 3 little dots on that router to represent those sub-interfaces that I would have created. And what we're going to do is we're going to have a source and destination for some traffic now. So we're going to have somebody sending from the 192.168.10 network to that person in the 192.168.20 network. As always, the traffic leaves the personal computer untagged, arrives on an access port, and gets tagged as being part of VLAN 10. Now, the sender would have gone through the effort of finding out the destination MAC address as the router's MAC address. Yes, the router will have a MAC address. And the switcher's MAC address table will then know, okay, I need to send the traffic out of the trunk port. So out we go. But because it's a trunk port, it's got to travel with the VLAN 10 tag attached to it. Now it's on the call switch. The call switch will do the same thing. It'll see the destination.
Okej. Mam wodę. O kurde, ale... Nabiło się. Dziwnie się nabiła. Znaczy totalnie. No cóż, jest dobra. Jest git. Dobra.
Destination MAC address as the routers and know to send it out of that trunk port that takes it to the router.
Tak.
It
Do
arrives on
routera,
the
na
router's
routerze
physical interface,
zmienia...
and then the router goes, I've got no config on my physical interface, but I've got these virtual sub-interfaces. Let me ask any of them if they know what to do. And the sub-interface I create for VLAN 10 will step up and say, yes, I'll take that. And it'll also rip off the VLAN 10 tag because the router just treats this as an ordinary IP packet. It just happens to understand how to recognize an 802.1q tag and remove it, at least when it's coming in. The router will then do its normal routing operation, looking at source and destination IP address, deciding what to do with it. And it'll move it to the appropriate outgoing interface, which happens to be a sub-interface under the same physical interface that we set up for VLAN 20. Now, being a sub-interface that works with VLAN 20 and being the outgoing interface, it will impose or add the VLAN 20 tag. When I say it terminates it, it doesn't just kill it. It just acts as an endpoint. So if something's going to go into that VLAN, it'll add the VLAN tag so it can work. And now that router and that corresponding sub-interface can send that packet out. This time, though, it returns to that call switch with VLAN 20 tag on it. And now, because the router would have gone through the effort of finding out the destination MAC address of the recipient, again through OP, the switch knows, okay, it must go out that interface, and it's a trunk port, so it better go out with its VLAN 20 tag. That traffic now arrives on that access switch, and that access switch will see the destination MAC address it saw on that interface before, and see it's an access port, so when it sends it out, it will strip away the VLAN 20 tag, because the end user PC probably doesn't deal with 802.1q very well. And voila, the traffic is now from the recipient. Beautiful. But what if I want to do this with a layer 3 switch? Well, let's check that out. Layer 3 switches, also known as multi-layer switches, are both a layer 2 switching device, and they also have an internal routing capability. If I were to visualize that for you, you can imagine the switch being a switch, but logically inside it's got a division, and in that division sits a little logical router. And we can have traffic logically sent to this little mini router inside from any of these physical interfaces that the end users might be connected to, or even trunk ports even. And this will allow our switch to perform some routing operations. Now, why would you want a layer 3 switch though? Well, there are some situations where it's going to be a lot more efficient to do a layer 3 switch rather than layer 2 switches and a dedicated router. But for now, let's see how will the layer 3 switch handle the routing. Well, let's diagram it out. Now, almost the same diagram, but please note the router is gone, and now we've got this layer 3 switch here. Now, 3 switch handle the routing.
Zanim to przesunie. Multi-layer. Dużo krótsze zdanie nawet. I'll switch to from routing operations for VNS. To fajnie było też pracować. Jako takie większe urządzonko. Czemu? Prawo, lewo. Może mieć kolorki. Ale tutaj ten. Jeden. Drugi. Oj, nie wiem trafić. I trzeci. będzie teraz
Well, let's
końcówka, czyli
diagram it
ten
out. Now,
diagram.
almost the same diagram,
Ponownie.
but please note the router is gone, and now we've got this layer 3 switch here. Some vendors might use a separate symbol for a layer 3 switch. Usually what I do when I'm doing a diagram is I'll normally just label it somehow as a layer 3 switch. For now, the little red star can do. So we're going to go create virtual interfaces on this layer 3 switch for the VLANs. We often refer to them as a VLAN interface, at least that's the common name. And what we're going to do is indicate those little interfaces with the same types of 3 dots we did on the router there. And
Okej, czyli robimy tak samo, dosłownie. Elo. Hop, hop. Ciup, ciup, ciup. Pa, pa, pa. Pa, pa. Pecety. Znaczy urządzenia, bo nie, nigdy nie odpowiemy. Laptopy, nie laptopy, pecety, może tablety, może... Nie, telefon raczej nie. Czy tablety raczej nie są fizycznie są periotek. Pa, pa. Pa, pa, pa. Robimy to samo, czyli no 10 0. Ej. 20 0. 0 9 pyk pyk 5 0 plasowe. Pa, 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 pa. Oj, woda prawie by mnie zacięła. Jest tak. Create virtual interface or either on their free.
And now I can go and set IP addresses on those VLAN interfaces as though they are default gateways. If I have to do any additional configuration, that will vary by vendor. But some of the vendors I deal with, it's as simple as just set up VLAN 10, 20, 30 on the switch, make your trunk ports, whatever you need to do, normal VLAN setup. And once you've done that, you have the ability to immediately create a VLAN interface, and you just have to link up the interface by saying interface VLAN IF10. Can be that simple. Other vendors, it might be a bit more involved to enable the layer 3 switch capability and the VLAN interfaces. So it does vary by network vendor, I'm afraid. Now, let's see what's going to happen if we do some transmissions. Let's use the same source and destination as earlier. And chances are you're probably working ahead of me right now, and you're probably making some very good guesses about how this works. The traffic begins on that source computer, travels untagged as always, arrives on the switch, and gets
Sami
tagged
to
as being part of
zapiąć
VLAN 10 because that's the VLAN that access port is a part of.
Teraz
Now, the destination MAC address for the default gateway will be the core switch's base MAC address. All network appliances have MAC addresses so we can communicate directly with them. And switches are no different. They have an internal MAC address so that if I need to speak to that switch specifically for whatever reason, be it remoting into it, or in this case, it's a layer 3 switch, it has a MAC address I can target. So that MAC address would probably be in that switch's MAC address table for that interface. So out it goes the trunk port, and remember when you go through a trunk port, you got to be tagged as part of VLAN 10. or at least a specific VLAN. Now, that traffic arrives on that switch. That switch sees, oh, it's destined for the gateway. And the way it knows that is it sees its base MAC address as the destination MAC. And that switch then passes it to the appropriate VLAN interface.
Right.
The way it knows that, the VLAN interface is tied to VLAN 10 in this case. And the traffic is tagged as being part of VLAN 10, so it knows where to put it. Now, it's going to do the same thing as the router. It'll strip away the VLAN tag, it'll perform a routing operation and move that traffic to the appropriate outgoing interface and get ready to send that out. As it goes out the appropriate interface where the recipient's destination MAC address would be known. And that traffic, as you can imagine, will be tagged as being part of VLAN 20 this time, just like it was with the router. So that when it arrives on the next switch knows this belongs to VLAN 20. As always, the access switch sees the destination is accessible on an access port, and it will send out the traffic without a VLAN tag. Pretty straightforward. Now, a concern you might have is this is all well and good. This is really cool. This is neat. But now, how are we going to be able to get traffic routed to other networks where we actually are using a router? Well, we can integrate layer 3 switches with routers. So if we have that layer 3 switch there with the lazy man symbol for a LAN segment there, and we put a router on the other end, and there are some other networks that router is going to get us to, we could be relying on OSPF for the rest of the routed infrastructure. Now, what I normally like to do is I will go and create a VLAN. Like, for example, I might go create VLAN 99. And then I would use 192.168.99.0 as the network address for that LAN segment. And I'll go and sign .1, for example, or 192.168.99.1 to that router's interface there. I will then go create a VLAN interface 99 on that layer 3 switch and give it the IP address 192.168.99.2. Good idea when you do that would be to ping it to make sure it works. What I would have to also do is make that an access port for VLAN 99. Otherwise, it should work fine, and we should be able to ping the router or the router ping that interface either way. If you're using a good layer 3 switch, it should support OSPF, which means I go and set up OSPF as I would on a router. I go and set up network advertisements for link state advertisements for network 192.168.99.0. And that should allow me to then also have the network advertisements traveling back and forth, and that VLAN interface and that router will discover each other. They'll become friends and they'll begin exchanging routes. Now, to do the proper routing, I'd also need to make sure I tell OSPF running on that switch to also advertise the network addresses for the respective VLANs that it is acting as a gateway for. So that in effect, I'm letting the little logical router in here talk to the actual router. But you know what? Any routing protocol could be used. You can even use static routing as well, if you so wish. I would probably go with OSPF though, because I'm only doing 3 VLANs here at the moment, so not too much work for static routing. But you never know how that's going to grow and evolve. Because that's one of the big benefits of VLANs is that they are very scalable and flexible. So I'd go for a dynamic routing protocol just for my sanity again. Not that I have much sanity left anymore. Now let's have a look at VLAN uses. What are they good for? So first up is security. With VLANs, we are able to create separate IP subnets that need layer 3 forwarding, basically routing, to get traffic back and forth. Now, if we have a situation where layer 3 forwarding is present, it allows us to do things like traffic filtering via an access control list, which we'll cover in a later video. We could use traffic filtering via firewalls. We could also have an easier time identifying where traffic comes from. So if anyone's up to mischief, I can look at the source IP address and have a rough idea where they are in the organization. And it helps limit the spread of malware, as we said earlier. And I could even use it as a way to place wireless LAN traffic in a dedicated VLAN. And I can also use VLANs for easier and cheaper guest isolation, making sure that guest networks, whether they be physical or wireless LAN connections, are in their own dedicated VLAN. Ideally, I would personally like to have a dedicated physical network for guests that is separate to staff members, so that the guest doesn't have an opportunity to try and escape the VLAN, for example, and hop onto a staff network. But that costs a lot of money, and the organization might not be keen for that. So using VLAN to isolate guests is not bad. Just be aware though, there are techniques that hackers can use to do VLAN escape. But another benefit we have is we get better network performance. As we said earlier, benefit.
Tak, bo wilany są bardzo tępe i... Znaczy nie wilany, zwykle są bardzo tępe. I po prostu tylko przetwarzają. Też filtering via firewall. Firewall powinien to sobie poradzić z tym. Navigation of sources i... Mhm. Okay, this is
We have is we
isolation.
get better
Sure.
network performance. As we said earlier, when the broadcast domain is reduced in size, it means fewer devices are processing broadcasts that will never be useful to them. So, bonus! We also have the opportunity to prioritize traffic more easily because we could apply quality of service, which we'll touch on in a later video,
Well,
to a VLAN.
course.
I could dedicate VLAN for voice over IP. So that again, I can prioritize voice over IP, possibly even dedicating a bit of bandwidth to it. I could also do VLANs for IP security cameras to maximize the quality of the footage. And I can do VLANs for VIP users. Please note, VIP users don't mean the fancy big shots necessarily at the workplace. It normally means users that are very important to that operation of that organization. You will have people that are mission critical and essential, and people that are not. And VLANs for wireless LANs also again help us with improving performance, which we'll talk a little about when we do the wireless LAN section. We're also going to benefit from a simplified design.
Devices, devices processing. Kurde, nie mogę patrzeć na obraz i ten i pisać, bo rozwalam po prostu całkowicie ten. Rozwalam sobie całkowicie pismo, spójrz głupoty. Zdania wyżej. Jak VoIP. Nie jest, że tak dawno tego nie widziałem. Security. I jest końcówka. Okej. I tak bardzo końcówka. Naprawdę.
Wireless LAN section. We're also going to benefit from a simplified design and support for our network. We're going to be able to move LAN segmentation to a logical approach, which means simpler physical topologies can be achieved. And believe me, simpler physical topologies are way easier to make redundant. So we're going to have an easier to manage network that is also going to be a bit more reliable if we start introducing some redundancy, which we'll discuss in another video. Then we could also make troubleshooting a lot easier, again, because a simpler network is easier to isolate faults in. And fewer pieces of hardware means fewer physical things to check for if we suspect a physical fault. And we can relocate devices and users from one LAN to another via a configuration change rather than having to run around and move them to a physically different device, which is pretty cool from a support perspective. And then finally,
Co? Ale dużo jest. Ja już nie pamiętam, że to jest tak dużo. Miecz. Maintain. Redundant. Gdzie się tak pisze? Taką rękę. Okay.
we can experience cost savings.
Cost savings,
Because the
tak.
port density and forwarding capacity of a switch is far greater per dollar, or whatever currency you prefer, than a router's. Now, don't get me wrong, routers are great, they're really fast, but per port and overall forwarding capacity of a router is generally lower if you use the same price point to compare a router's performance to a switch's performance. At the end of the day, it's not unusual to see switches with 16, 24, or even 48 ports used in a user access area. Whereas to find a router with that many interfaces, those are not cheap, and they're very, very specialist and more likely to be used by service providers. So routers are generally going to be less ideal than switches for VLANs and LAN segmentation. Routers are generally better at dealing with the physical media and encapsulation standard change between a LAN and a WAN connection, such as Ethernet to whatever your service provider is using as this layer 2 WAN standard. Also, you can use bottom tier enterprise switches that support VLANs as long as they're managed. Through my experiences, almost every enterprise switch, even if it's at the bottom end of that vendor's product offering, will support VLANs as long as it's this manageable switch that I can log in and apply configuration to. And this will actually help us a bit because it also means my router's performance can be focused on traffic forwarding between different parts of a building or the campus, or forwarding traffic to my ISP. So all of that performance can be for that. And then the switch takes over the worrying of moving traffic around and forwarding between people in the same part of the building or campus. So a fantastic way to get the most value for money out of a switch and a router by using them in ways that
Ojejku,
play into their strengths.
żeś wróciła. Ja już praktycznie kończę ten segment i kończę też całkowicie. Jest ta pierwsza prawie. A nie chcę też siedzieć nie wiadomo ile nad tą nauką. Ła, ta ręka już boli. 3 godzinki. 3 godzinki nauki, masakra. Encapsulation, tutaj sobie wpiszę Ethernet. Jezus. Potom pier. Ja też od 20 minut już kończę mapę. Już. Enter. Mhm. Jeszcze, ale sort of customer and traffic forwarding też on traffic for mhm. W Wordzie spisie też zmienić czcionkę cyferek. Ojejku. Robiłem to kiedyś. Robiłem to kiedyś. Dokument. Halo. Okej, załączę sobie szybciutko. Z dokument. Nie chcę ten. Kupić z listą? Cytaty nie. Bo ty robisz nagłówek. Elo, elo, na przykład. Nagłówek z stylu drugiego. Hi, hi. Tam się chyba chodziło w style? Pamiętam? Modyfikuj. Normalne. To jest tak. Na podstawie... Nie, nazwa nagłówek 2. Okej. Mm, czcionka? Się chyba zmieniało? Nie przypominam sobie, jak cyfry się zmieniało. Poszukam ci tego później. Na pewno to będę, a nie chcę, żeby po prostu telefon też padł. Kamerka z tego telefonu będzie nie jest najlepsza. Udało mi się. Znaczy, jak wejdziesz na edytor, na ten nagłówek, który używasz, prawym przyciskiem myszy powinnaś mieć edytuj styl i tam zmienić. I... e, Muszę zmieniać to za każdym razem, jak edytuję spis treści. Dlatego mówię, że trzeba edytor styli wejść, nie? Bo w każdym spisie są. Okej. Okej. Building campus. Dobra, wystarczy.
Than trying to make it an all-in-one device.
To już wywalę.
Now, I'm hoping that gave you a good overview for how
Oh.
VLANs work, because that's all I want to cover with you for the basics of
O
VLANs.
matko.
We are probably going to revisit VLANs a little bit more in this course because it is part of the Network Plus
Zjechało
syllabus
mi to.
to go a
Yep.
bit beyond this now. However, I would like to say thank you for watching. I hope you enjoyed it and you have a better understanding for VLANs. And if you have any friends, family members, colleagues, peers, etc., who are also interested in Network Plus, don't be afraid to share this video with them.
O. Trzymam sobie. Telefon zostawię do włączenia. Nie wiem, ktoś się bawi cały czas tym miejscem. Dobra. Ojejku. Zobaczmy, co się dzieje. Tu. Coś jest. Chcę wysłać was tam. Już wiem. Już wiem do kogo. Dobra, pora. Pystek. To ci pokażę. No. Wróciłeś w najlepszym momencie, jaki można zrobić. Czyli inaczej mówiąc. Well. Bajo. Jajo. Bo będę uciekał. Haj, haha. Tak. Idę sportować. No sorry, ale 3 godzinki już mi starczą, naprawdę. Ja siedziałem teraz cały czas nauka i to jest cały dzień mój po prostu wolny na to spędzony, poza tym, że byłem u dziadku. Do dziadków sobie poszedłem, bo wiadomo, troszkę trudno jak się pracuje, żeby po prostu do nich pójść. A teraz po prostu te 3 godzinki takiego siedzenia, telefon mi prawie padł z tego. No, a ja spisałem 2 tematy zamiast jednego. Myślę, że jeden sobie zrobię. Pójdę na gierkę, uznałem, a dobra, walić, zrobię 2, bo jestem bardzo mocno do tyłu. Bo jestem tu jestem na 12, a jestem chyba na 17. a nie chcę tej wiedzy po prostu zapominać, bo tak to sobie po prostu mniej więcej to utrwalam. Jeżeli jestem dwa na przykład do tyłu, to jeszcze jest git. Więc troszkę tego jest. No, tej wiedzy jest masa, naprawdę. To, co jest tutaj opisywane, to jest jeszcze taka bardzo podstawowa. Więc w takim razie miłego, bawcie się dobrze. Ale tego radzika